Hey everybody, last class we looked at the Pythagorean theorem in the coordinate plane and did an activity trying to create for yourself the distance formula. So that's what we're going to briefly go over again today, just in case you didn't understand it. And then we'll do some practice problems out of the textbook. So Pythagorean theorem says this, that if you have a right triangle means 90-degree angle, then if I find the sum of the square of the legs, a squared plus b squared, that will equal the square of the hypotenuse, right? This right here, a squared plus b squared equals c squared. It turns out if we are in the coordinate plane, which I'm going to use this example down here, if I have 2 points in the coordinate plane, I might label them x1, y1, right? At first x coordinate, first y coordinate, and x2, y2, like this. And if I wanted to find the distance, the shortest distance between these points, which is this line here that I'm drawing, it's basically the Pythagorean theorem, because I can draw a triangle like this, and you can see that this a value would be given by the difference in the y values, right? So the a value would just be subtracting the y coordinates, y2 minus y1, and this b value would be subtracting the x coordinates, x2 minus x1. And so the distance formula, and we're going to go ahead and call this side D. So the distance formula becomes x2 minus x1 squared plus y2 minus y1 quantity squared. And if I do that, that will give me my distance squared, like such, right? And I could take the square root of both sides if I chose to, right? So let's look at this example here that we're given down in this coordinate plane. I'm trying to find the distance between these 2 points, as if I could just walk straight there, right? So we can consider, if you consider the triangle, right, of going straight down and straight over, this side length, let's call it A here, would be determined by, see how the x coordinates are 3 and 6, so the distance would just be 6 minus 3, right? And this y coordinate here would be determined by doing subtracting the y coordinates. You can see the y coordinates are 6 and 2, and so this is going to be 6 minus 2, which is 4, right? And so putting this into the formula, basically we're just getting 6 minus 3 squared plus, subtract the y coordinates, we have 2 minus 6 squared, and that should give me my distance squared. If you do this, you get 3 squared plus negative 4 squared equals d squared. So that's 9 plus 16. Remember, squaring a negative gives you a positive. And then 9 plus 16 is 25. Therefore, d squared is 25. In order to actually finish solving this equation, we should take the square root of both sides, right? And then we'll get d equals 5. So it turns out this side length, this distance from there to there, is exactly 5 units. And it won't usually turn out to be such a nice number as that. All right, so let's look at another example, or a more real-world example. On a map, maps have coordinates. It is a coordinate plane. We're using latitude and longitude. Let's pretend we're in a boat, right? We're over here in this boat at coordinates 7.7, 2.5, and we're trying to get to Robin Hood's Bay. We want to get there in the shortest distance possible, which would be taking a straight route like this. If we want to know our distance, we can use the distance formula, which is basically just Pythagorean theorem, by finding the x and the y distance, right? And we can just plug these into this formula. So we subtract the x coordinates. So in this case, we're going to do 7.7 minus 2.5. We're going to square that. We're going to add that to subtracting the y coordinates, which is 2.5 minus 4.6. Square that, and that will give us distance squared, and the distance we're talking about is this. All right, so we do this math. 7.7 minus 2.5 should be 5.2, and 2.5, so we got to square that. 2.5 minus 4.6 should give us, let me do this. That gives us negative 2.1. squared, and this whole thing should be equal to d squared. Then we square these, right? 5.2 squared is 27.04. Negative 2.1 squared is 4.41, and that's equal to d squared. If you add these two together, you get 31.48. And then you take the square root of both sides, right? Square root, square root. Also keep in mind, usually when we do square roots, you have a plus and a minus, but we're talking about distance, so you cannot have a negative distance. Here we get 5.61. And then we want some units on this. It's nautical miles. This is 5.01 nautical miles. All right, so that's this distance. It's 5.61 nautical miles, right? You've successfully found it. Okay, so your assignment for today is to practice these skills out of the textbook. I'll post the exact page on and problems that you need to do, but it's out of this new textbook. And then you should be uploading your work onto ManageBack and reaching out with any questions that you have.